Hello again. We're looking at dihybrid crosses still, and this time we're looking at a couple of traits in mice. One of them is fur color, where they tell us that the big B allele gives us a black furred mouse, and a little b allele gives us a brown furred mouse. And then there is a big N for normal allele, and there's a recessive trait that they call waltzer. The waltzer trait is a defect in some of the sensory cells inside the ear, and it causes deafness. And in the semicircular canals, it causes problems with balance, so that a waltzer mouse actually has trouble walking in a straight line because of its balance problem and tends to walk in a curve. It may go in a whole circle at times because it's not able to orient itself properly. So those are our two traits. And let's see what they tell us about parents here. Two mice that are heterozygous for both traits are crossed. Okay, so we have a mom who is big B, big N, little n. That means she is black and non-waltzer, and dad is the exact same way. Big B, big N, little n. Draw a Punnett square for the F1 generation. Determine the phenotype ratio of these offspring. Okay. Well, double heterozygous, we've seen this pattern before, and we kind of know what comes from it. We expect to see a 2 to 1 ratio. Sorry, not 2 to 1. What am I doing? 9 to 3 to 3 to 1 is the expected breakdown from a cross like this. When you have double heterozygous parents, we should see 9331, and let's see if that's the case. So from these parents, to fill in the edges of the Punnett square, we need to figure out what the possible gametes are from these, and you can FOIL that, or you need to find every possible combination of B alleles and N alleles. If you FOIL it, you get the first B and the first N. Outside, first B, last N. Inside, little b, big N. And last, little b, little n. Those are the eggs that mom can produce, and dad, being genetically identical, will produce sperm cells with the exact same thing in them. So let me scoot this over to the left a bit because I need the space, and we'll get our gametes onto the Punnett square, and we'll get to work. Big B, big N. Big B, little n. Little b, big N. Little b, little n. And exactly the same for dad. Little b, little n. Okay. And I'll type this because it goes a tiny bit faster, I think, and it's probably a little easier to read. Big B, two big B's and two little n's. Big B, big N, little n. Big B, little n, little n. Big B from dad, little b from mom. Big B from both parents, or big N from both parents. Big, little, little. Little, big. Little b's, hetero n's. Hetero b's, hetero n's. Hetero b's, little n's. Little b's, hetero n's. And little b's, little n's. Okay. So, going back through this again, what does that give us for phenotypes? Big B means black, and big N means normal. These are black normal. Black normal. The whole top row is black normal. Big B means black, and that's normal again. Big B for black. Little n's means waltz. Big B means black. Big N means normal. and waltz again. Big B means black, big N means normal, black normal, meaning non-waltzer. Little me means brown, I'll put BN, and big N is normal, brown and normal, black because of the big B and normal, black because of the big B and waltz. Little b means brown and normal, and brown and waltz. Okay, so combining gametes. I'm putting B's before N's, I'm putting dominants before recessives, no matter what parent they came from, and that gives us our offspring. If you want the genotypes, here they all are. Each of these is 1/16 of the total. And if you want the phenotypes, let's count. I'm reasonably sure we're going to get 9331, but let's pretend we don't know. Black normal for 1, and 2, and 3, and 4, and 5, and 6, and 7, and 8, and 9. 9, black normal. Or you can say 9 out of 16, and if you want a percentage, do 9 divided by 16 times 100. What other kinds of mice can we have here? Black waltzer, and 2, and there are 3 black waltzers. No one is surprised. Black waltz. Brown normal, and there's a brown normal, and there's a brown normal, so we have 3/16 of the offspring will be brown non-waltzer. And that leaves one who is double recessive, and they are a brown waltzer. Easy enough.